This video is on Chapter 8, Lines. Now, lines are something that I'm sure you've studied before in pre-calculus class and algebra classes, so the only thing I'm going to do from this chapter is go over the picture of the proof of Theorem 62, because there's some description in that proof, but this picture would complement that description fairly well, I think. And so the Theorem 62 says that if you have two lines with slopes m1 and m2 that intersect, then the lines are perpendicular if and only if m1 times m2 is -1. In other words, they're opposite reciprocals of each other. And so we start with our point AB. This is where they intersect. So the point AB is on both lines. One line has slope 1, or slope m1, and the other line has slope m sub 2. And so if you look at, say, the point slope form of the line, we would have y minus b is equal to m sub 2 times x minus a. So add b to both sides. And we can rewrite this line as m sub 2 times x minus a plus b. Likewise, the point slope form of this line would be y minus b is equal to m sub 1 times x minus a. So add b to both sides, and we have y is equal to m sub 1 times x minus a plus b. So we have the equations of both of our lines in the point of intersection. Now, horizontally, we move one unit to the right and look at the point a plus 1, where x is equal to a plus 1. The reason we do that is it makes the algebra a little bit nicer. So we move along here, a plus 1, and we substitute a plus 1 in for x right here in this first line. So a plus 1 minus a is 1. And so our y is m sub 1 plus b. This is where the point a plus 1, m sub 1 plus b on line L1 comes from. In the notes I named this line L1. Likewise, when we move to the right one unit, a plus 1, and we look at the point on L sub 2, we substitute a plus 1 in for x right here. A plus 1 minus a is 1, so we have m sub 2 plus b. So we have the point a plus 1, m sub 2 plus b on the second line. It's nice here, this is a vertical line. So this distance between these 2 points is really just the absolute value of m1 minus m2, which we can also write this way using the distance formula. So now we looked at the triangle whose vertices were these 3 points right here. And we calculated this distance using the distance formula. So we have a plus 1 minus a squared is 1. Then we have m1 plus b minus b squared is m sub 1 squared. So we have the square root of m sub 1 squared plus 1 is the length of this side. Likewise, when we go from the point AB down to this point, we use a distance formula. We have a1 or a plus 1 minus a squared, so we have 1 squared. Then we have m sub 2 plus b minus b squared, so we have m sub 2 squared. And then we take the square root of the sum, just like we did here. This side is going to be m1 minus m2 quantity squared under the square root. That's where those came from. Then when you look at the notes, we noticed that this side squared plus this side squared is equal to this side squared. And so by the converse of the Pythagorean theorem, we see that this is a right angle. And so we have a right triangle. In the notes, there's a series of if and only if statements, because Theorem 62 is itself an if and only if. So in other words, these two lines are perpendicular if and only if m1 times m2 is -1.